Dear students, today I have the topic latent heat. We studied about change of state of matter in the previous classes, and we have seen the changes take place inside the matter during change of state of matter. And today's topic is latent heat. So latent heat. So from the name itself, you can understand that it is something about heat energy, and it is related to what change in temperature. So we will consider an example of melting process, melting of ice. So for melting of ice, we need solid ice cubes which will melt at its melting point and turn into water. This is the melting of ice. Suppose if you want to perform the experiment of melting of ice, okay, if you want to show the melting process of ice, for the experimental setup will be like this. That is, we need a beaker. Beaker is an instrument which is made up of glass. We need beaker, and inside the beaker we have to put the ice cubes. So ice cubes are in the uh, solid state, and inside the beaker we have to place a laboratory thermometer. So what will be the purpose of thermometer in this experiment? Because thermometer shows the change in the temperature. Okay, we can understand the change in temperature during melting of ice. For understanding the change in temperature, we need a thermometer. So it is available in the lab. So we have to insert the laboratory thermometer into the ice. So the bottom of the thermometer is with the ice cubes. So it means that whatever the temperature shown in the thermometer will be the temperature of the ice cubes, because we dipped the thermometer inside the ice cubes. So the temperature shown in the thermometer will be that of the ice cube. So we are going to checking out the temperature changes during melting. So this is the actual image of thermometer. Then how can we know the change in temperature? So from the thermometer we will get the temperature value at the moment. So we can understand that using, how can you see a red line which inside the, see the red line starts from here, and in this image red line is till here. So this red line, the movement of red line shows the temperature. So it starts from here. We can see minus 20 temperatures are marked, minus 20, minus 10, 0, 10, 20, 30, 40, etc. Now you can see that the red line in the thermometer is between 20 and 30. I think it's about 25. That means the temperature shown in this thermometer is 25 degrees Celsius. Then suppose if the temperature increases, if it is above 25 degrees Celsius, the red line will be like this, it will extend. So this movement of red line, from the movement of red line we can get the temperature value. So this is the significance or use of thermometer for getting the temperature values. So in this experiment we can visualize the experiment like this. These are the three images. Using this image we will explain the melting of ice. And for this experiment we need beaker. Then inside the beaker we put ice cubes. Then insert thermometer in the beaker. Then we need another, that is we need burner. We need burner. So what is the purpose of burner in this experiment? Because we have seen that this process melting takes place on heating the solid. So here the solid is ice. So we have to heat the ice. Then only the ice becomes water. So that's why we used here burner. So we have to heat the ice cubes. We have to heat the ice cubes continuously. So when you heat it continuously from the beaker, the ice cubes will get enough heat energy for the melting. This is the process. And in this image we can see that this shows the temperature on the thermometer. So when you before you start this experiment, suppose the initial temperature of ice cube is minus 15 degrees Celsius. Ice cubes, they always exist in negative temperature below 0 degrees Celsius. Suppose the initial temperature of these ice cubes which we have taken is minus 15 degrees Celsius. That is actual temperature of the ice cubes before you start heating before you start heating the initial temperature on the thermometer shown is minus 15. Suppose it is minus 15, then you start heating, and when you start heating, initially there will be no change in the thermometer, so gradually there will be change. That is the red line, like this red line will move up. So after some time, after one or 2 minutes, you will see the temperature increases. That means the red line inside the thermometer move upwards. That means temperature increases. Minus 14, now it is minus 14, then we after few seconds minus 13, then minus 12, minus 11, minus 10, like this it increases. Then after some time it will become above minus 10, minus 9, minus 8, like this. In this figure it is above minus 10, like minus 9, minus 8, then it reaches minus 6. That is, the temperature is gradually increasing. Initially only this much, the temperature is increasing. Minus 6, minus 5, minus 4, minus 3, minus 2 degrees Celsius. We can see the change. Minus 1 degree Celsius, like this. Then after minus 1, the temperature, the line reaches on 0 degrees Celsius. But after reaching the 0 degrees Celsius, we can see that after, so suppose this happened, the temperature reached 0 degrees Celsius, it happened after 5 minutes, suppose. Then again after 5 minutes, we are again checking the temperature changes. So but after 5 minutes, then the time is 6 minutes, but still the temperature is 0 degrees Celsius. Then we will check again the temperature in 7 minutes. After 7 minutes, again 0 degrees Celsius. Then again the temperature remains constant 0 degrees Celsius. So till minus 1, from minus 15 to minus 1, when you heat it, there will be a gradual change, the temperature increase. But when it reaches 0 degrees Celsius, the temperature remains constant. So we know that melting point of ice is 0 degrees Celsius. We studied already. That is, when solid melts, its temperature remains the same. That is, when solid undergoes melting, that melting point remains the same till the entire solid changes into liquid. So this 0 degrees Celsius will remain there till the whole ice cubes become water. So this melting of ice just started only the temperature when the temperature reaches 0 degrees Celsius. At that time the ice cube starts melting. But the whole ice cubes cannot melt at the same time. It takes time. So we know that here large amount of ice cubes we have taken here. Suppose 10 gram ice cubes are there. So when the temperature reached 0 degrees Celsius, the whole 10 gram ice cubes cannot melt at the same time. Initially the ice cubes which are at the bottom of the beaker will melt and form water, but the ice cubes which present on the upward area of the beaker will not melt initially. So it takes time. For example, if the entire ice cubes need 10 minutes for melting to change into water, till 10 minutes the temperature on the thermometer will remain the constant, that is 0 degrees Celsius. So we can conclude that whenever a solid undergoes melting, the melting point remains constant till the whole solid changes into liquid. Now the question comes is that initially till minus 1 degree Celsius we have seen the gradual change. But after reaching the melting point of any solid, the temperature remains the same. But we don't stop heating, we still heat it. We didn't off the burner after reaching 0 degrees Celsius here, but we still heat it. The ice cubes are getting heat from the burner, but the temperature, there is no change in the temperature. So where does the heat energy go? So we are heating it, and till 10 minutes time the temperature remains constant 0 degrees Celsius, no change in the temperature, but the ice cubes are getting heat from the burner, but there is no change in the temperature. Then so where does the heat energy go? The heat energy is called latent heat. So during melting, after reaching the melting point of solid, that melting point remains, the temperature remains constant till the entire solid changes into liquid. So at this time, so whatever the heat you give from the burner at this time, that heat is called latent heat. So students, when a solid reaches its melting point, after reaching the melting point, whatever the heat you are giving, that heat energy is called latent heat. So what is the importance of latent heat is? So what is the difference between latent heat and normal heat? So we'll see about that. So in the case of solids, we know that there will be a proper order of the particle like this. There is a regular arrangement of particles, and the particles are closely packed like this, and they can only vibrate at their fixed position. We studied all this. So inside the ice cubes, this large amount of particles are regularly arranged and they just vibrate at their position. So this is the arrangement of the particles in the ice cubes before you start heating. That is minus 15 degrees Celsius. This is the setup. So when you start heating, the temperature, what happens? From the burner, the ice particles are getting heat energy. So when the particles are getting heat energy, we know that we studied in the previous session, the temperature is directly proportional to kinetic energy. So when the temperature we are continually heating, so therefore the particles are getting temperature from minus 15, minus 14, minus 13, minus 12. So as the temperature of the particles increases, what happens? The kinetic energy increases, because temperature is directly proportional to kinetic energy of the particles. So if the kinetic energy of the particle increases, what happens? The more movements means more vibration. The speed of the vibration of the particles increases. So this speed of the vibration actually recorded by the thermometer in the form of change in temperature, like this: minus 13, minus 12, minus 11, minus 10, minus 9, minus 5, minus 4. These temperature changes are actually just representation of the speed of vibration. That is, as the more heat energy gets, the particles, the temperature of the particles increases. So as a result, the speed of vibration increases. This speed of vibration is recorded by the thermometer in the form of change in temperature. That's why you have seen the change in temperature from minus 15 to minus 1 degree Celsius. But when the temperature reaches 0 degrees Celsius, then there is a change. The change is that after reaching the temperature 0 degrees Celsius, the heat energy that absorbed by the particles is not utilized for increasing the kinetic energy. It is utilized for breaking the force of attraction. So this is the main point. Whenever the solid reaches its melting point, whatever the heat energy it gets, it is not utilized for increasing the kinetic energy or speed of vibration. It is utilized for breaking the force of attraction. So at 0 degrees Celsius, what happens? The heat that we are being supplied after 0 degrees Celsius is utilized for breaking the force of attraction between the particles. Then slowly the particles will break the force of attraction. As a result, the particles will separate, they start moving. Finally, they reach in the liquid state. So this happens during melting. So after reaching the melting point, the heat which we are supplied is not utilized for increasing the kinetic energy. It is utilized for breaking the force of attraction. As a result, the solid will be changed into liquid state. This heat which is utilized for breaking the force of attraction between the particles is called latent heat. So that's why after reaching 0 degrees Celsius, we have seen that for 10 minutes time till the entire 10 gram ice cubes melt to form water, the temperature remain constant at 0 degrees Celsius. So the this 10 minutes time, during this 10-minute time, whatever the heat the ice particles get is utilized for breaking the force of attraction, then it helps to change it into liquid state. So this heat that absorbed by the ice particles after reaching 0 degrees Celsius, after reaching its melting point, is called latent heat of ice. Okay, now we have the definition of latent heat. The heat energy which has to be supplied to change the state of a substance is called its latent heat. The clear definition we have: the latent heat is the heat energy which supplied for overcoming the force of attraction between the particles of a substance during the change of state. So during the change of state means any process. It can be melting, that is solid to liquid, or condensation, or boiling. So whatever the change of state of matter, uh, during all the change of state of matter, the temperature remains constant. Why? Because the heat energy which supplied are used for remove the force of attraction between the particles. It is not utilized for the movement or increasing the kinetic energy of the particles. So when a solid becomes liquid at its melting point, when that melting point is achieved, after that the melting point, the particle temperature will remain constant till the entire solid becomes liquid. So similar is the case of other process. During boiling of any liquid, whenever the boiling point of the liquid reaches, after reaching the boiling point will remain constant till the entire liquid becomes gas. So what is the reason? Because the temperature is getting after the after the boiling point of that particular liquid, that heat is utilized for removing the force of attraction. It is not utilized for increasing the kinetic energy. So that's why there is no further change in the thermometer. So when ice starts melting, the temperature is 0 degrees Celsius. It will remain there. The temperature value of the thermometer will not increase. You will not see any further increase in the thermometer. That means the temperature remains constant at 0 degree Celsius till the entire ice becomes liquid. So at this time, during this time, whatever the heat you are supplying, this heat is called latent heat. This latent heat is utilized for removing the force of attraction. It is not for increasing the kinetic energy. So the temperature which is utilized for increasing the kinetic energy, only that temperature change will be recorded by the thermometer. But after reaching the melting point or boiling point, whatever the heat you are supplying, it is called latent heat. Latent means hidden. That means this heat energy is hidden inside the matter because it is utilized for overcoming the force of attraction. It is not utilized for increasing the temperature of the substance. So this hidden heat is utilized for removing the force of attraction between the particles during change of state of matter is called latent heat. So the latent heat of melting is called latent heat of fusion. We know that fusion means melting only. So what will be latent heat of fusion? The latent heat of fusion will be the amount of heat energy which required for the solid to remove the force of attraction when the solid starts changing into liquid state. So, for example, the temperature remains constant as the heat gets used in changing the state by overcoming the force of attraction between the particles. For example, a solid melts on heating, its temperature does not rise until the entire solid is converted into liquid. We can see that here the temperature will remain constant at 0 degrees Celsius. It will not rise, it will not increase until the entire ice is converted into water. So, this heat which we are supplying after reaching the melting point of solid is called latent heat of fusion. That is, the latent heat of melting is called latent heat of fusion. Specifically, we can define that the amount of heat energy which is required to convert 1 kg of solid into liquid at atmospheric pressure is known as latent heat of fusion. So specifically, here we are using 1 kg of solid. So the solid can be less than 1 kg or more than 1 kg. So for the general definition, we can write latent heat of fusion is the amount of heat energy which is required to convert 1 kg of solid into the corresponding liquid. This is the latent heat of fusion. Next, if you consider the process of boiling of water, there will be also what latent heat. So whatever the change of state of matter, it can be freezing, condensation, boiling, melting, there will be latent heat. That is, the temperature will remain constant for some time. Here, if you consider the boiling of water, for the boiling of water, if you perform the same experiment, we need beaker and thermometer. So inside the beaker we will take water. So water we have inside the beaker, and for checking the temperature we will dip the thermometer, and the thermometer will show the temperature of the water. So initially, suppose the temperature is 27 degrees Celsius. So the normal temperature, room temperature is 27 degrees Celsius. So before you start heating, the temperature on the water is 27 degrees Celsius. That means before you start heating, the original temperature of water is 27 degrees Celsius. Then after that you start heating using burner, and initially there are no changes, but after some time, after few minutes, there will be increase in temperature. The red line in the thermometer can be increased like this. You can see the rise like 28, 29, 30, 40, 50, like this temperature is increasing above 50, 60, 70, 80, 90, 98, 99. But after reaching 99, then next is 100 degrees Celsius, and we know that boiling point of water is 100 degrees Celsius. Therefore, what will happen whenever the temperature reached 100 degrees Celsius, we will heat, there will be further heating, but the temperature will remain constant. That is, if you check the temperature after 5 minutes, again it will be 100 degrees Celsius, then again 100 degrees Celsius, 100 degrees Celsius, there will be no change. That is, when the boiling point of water 100 degrees Celsius is achieved, the temperature in the thermometer will not increase, it will remain at 100 degrees Celsius. There is no further increase till the whole water becomes gas, that is water vapor. So this temperature will remain 100 degrees Celsius till the entire water becomes water vapor. Suppose if it needs 30 minutes, then till that time the temperature on the thermometer will be 100 degrees Celsius. Why? Because at 100 degrees Celsius the particles get enough heat energy to break the force of attraction. As a result, whatever the heat you supplied after 100 degrees Celsius will be latent heat. Means the heat will be used for removing the force of attraction, and finally the particles will be separated and they will move and becomes water vapor. Till that time the temperature remains constant, because during that time the heat which we supplied will be latent heat of boiling. So this latent heat is called latent heat of vaporization. So what happens during that time? So when the temperature is below 100 degrees Celsius, whatever the heat is getting the water particles. So these are the water particles, water molecules. Whatever the heat is getting, it is increased for, it is used for vibration. It is utilized for increasing the kinetic energy and the speed of the vibration increase. But when the temperature becomes 100 degrees Celsius, the heat which we supplied is utilized for breaking the force of attraction. So at that time, this heat is called latent heat of boiling of water, and specifically we can call it latent heat of vaporization. Vaporization is another name of boiling. Is the definition of latent heat of vaporization. Here specifically we will use the same 1 kg of the liquid, same definition only. In latent heat of fusion, what is that? Amount of heat energy which is required to convert 1 kg of solid into liquid. It is called latent heat of fusion. Then what will be latent heat of vaporization? The amount of heat energy which is required to convert 1 kg of liquid into gas. It is called latent heat of vaporization. So we can conclude that during change of state of any matter, it can be boiling, melting or freezing, the temperature, whenever the melting point or freezing point or boiling point is achieved, the temperature will remain constant till the entire substance changes into the next state of matter. What is the reason? That because whatever the heat is used for, it is used for changing, it is not used for increasing the kinetic energy, it is used for removing the force of attraction. As a result, the particles will change into the next state of matter. So that's why we will say that during change of state of any matter, the temperature remains constant. So this is the concept of latent heat. Thank you.